Alright, Unit 2, Lesson 2. Welcome back. Probability distributions of random variables, standard deviation, and expected value. Those are the main topics in this video, and these are the main topics of statistics in general. These will form a great foundation for your future learning. So, let's start off with some definitions. Where did we stop last time? Alright. So, first thing we're going to look at is number 8, discrete random variable. And we've already gone over this in, I think, the first video where we identified a variable and we identified what kind of variable it was. But I'm just going to give you a quick refresher because it's important for what we're doing here. So, a discrete random variable is a variable that has a finite set of values. So, that's something like 1, 2, 3, and 4, where those are the only 4 outcomes possible for the variable. A continuous random variable is a variable that has an infinite set of values. So our example there would be x is between 0 and 10. So that could take on any number between 0 and 10. Any decimal and any fraction, anything in between there is game, and that's why we call it continuous. So the next one is a probability mass function. And this is for a discrete variable, and it shows the possible outcomes along with the probability of each of the outcomes happening. And this is usually in a table, and we're going to see some of these later, and you're going to know what I'm talking about. Next term, expected value, and so we'll usually write this expected value with this right here. So it's e and then an x inside 2 brackets. So that's how I'm going to show expected value for the duration of my videos. And the expected value is the average or the mean value of the data. And it's usually calculated by adding up each outcome multiplied by its own probability. And I'm also going to use mu for expected value. So mu or e with x between 2 brackets, either one is fair game for expected value. Variance is the spread between the outcomes of a variable. And the formula for variance, when we're not going to use variance too much, the only time we'll use variance is to find our standard deviation. So the formula for variance this is just for a 3 outcome variable. So variance can take on many forms for the formula, but I'm just going to show you one with 3 outcomes because if we take more outcomes, it's going to be a lot more to calculate, and I didn't want to write all of that down. So here's the formula for 3 outcomes. So it would be the first observation minus the expected value or the mean, mu, squared, so this term is squared, and then multiplied by the probability of the first outcome. And then it's going to be the same for the next, so it would be the second outcome minus the expected value squared times the probability of the second outcome happening. Same for the last one, it's going to be the third outcome minus the mean squared times the probability of the third outcome. So the standard deviation is a measure of the amount of variation in the outcomes of a variable. And the formula for that, all we're going to do is we have our variance that we found, and then we're just going to take the square root of it. So square root of the variance, and that's basically all we need to know for this lesson. This one should be a little bit shorter, so let's go ahead and do it. All right. First problem we're going to start off with is let x be the number of rooms in a randomly selected house in Auburn. Describe the following events using the random variable x. So I have 4 number lines down here for A, B, C, and D, and we're going to use it for the problem. So the first one, the house contains at least 3 rooms. So I'm going to go ahead and put a circle here at 3, and then that means we're going to go all the way this way to the right. So it's going to be everything greater than 3, and at least 3 rooms contains 3. So I'm going to go ahead and fill that in there. And this is basically going to, and now we have to put it in terms of a greater than or less than symbol. So the house contains at least 3 rooms. If you can see from our number line, it would be x is greater than or equal to 3. Since we have a dot here, and then everything beyond to the right filled in there. So for B, the house contains at most 3 rooms. So let's go ahead and put another circle here at 3. And at most would be everything less than 3. And for this one, you're not going to be able to go beyond 0. So technically this is going to stop here at 0. And since it's at most 3, that means we need to fill in this bubble because 3 is included. So I'm going to go ahead and put x is less than or equal to 3 from our number line there. So for C, the house contains more than 3 rooms. I'm going to go ahead and put our open circle there and everything to the right of it. But this time, more than 3 rooms means it does not include 3. So since this is a discrete variable, which means you can't have a number between 3 and 4, this would technically just mean that we are 4 and greater. So there's multiple ways you could write this. You could say x is greater than 3, or x is greater than or equal to 4. Okay, so for D, again, we'll draw a circle at 3. It says the house contains less than 3 rooms. And so less than 3 means everything this way. And again, we have to stop at 0 because a house cannot contain less than 0 rooms. And since it's less than 3, that means we're not going to fill in this circle. So that is x is less than 3, or like we did in the last one, x is less than or equal to 2. So we moved over 1 and then just said less than or equal to because it's a discrete variable. Okay. Next problem. Suppose the random variable x has the probability mass function given by the table below. And remember, we went over probability mass function earlier, and I told you we were going to be seeing a chart like it soon. So in a probability mass function, if you remember from our last lesson, all of the probabilities of a variable have to add up to 1, right? So that means this plus 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 this. All this has to equal 1. So basically what we would do here is we would take the probabilities of 1, 2, 3, 4, 5, 7, and 8, add them all up, and say 1 minus the probabilities of these and these, 1 minus those added together, 1 minus that equals 1 minus, and I've already done this math, so that would be 0.95, and this gives us probability of x equals 6 is 0.05. So right, again, 0.95 would be the probability of 1 added to the probability of 2 to the probability of 3, 4, 5, 7, and 8, and that equals our 0.95. And then we take 1 minus that answer, and it gives us the last open variable we're looking for. So probability that x is less than or equal to 2. And remember, so what we did up here is for less than or equal to, which would be this part B, it is the filled in number at 3 on this one. So that means it can be that number and then everything less than it. So for this one, it would be the probability of 2 plus the probability of 1. So I'm going to write that down. I'm going to say probability of 1 plus the probability of 2. And that would be 0.25. And now, so for this next one, its probability x is greater than 2. So that is not going to include 2. That's going to be 3 plus 4 plus 5 plus 6 plus 7 plus 8. So I already have done that for us. So we can do 0.75. And now another way to do that, if you can see that the probability that we found in part B is the complement of the probability that we're supposed to find in part C. So if we did 1 minus 0.25, that also gives us 0.75. 2 ways to get our answer there. The second one is probably a little faster than adding up the other ones. And for the last part, it says the probability that x is 3, 4, or 7. So for that one, all we would do is say probability of 3 plus probability of 4 plus probability of 7. So that is going to give us 0.2 plus 0.03 plus 0.22. And this is going to add up to give us 0.45. Okay. An insurance for an appliance costs $51 and will pay $519 if the insured item breaks plus the cost of insurance. The insurance company estimates that the proportion 0.02 of the insured items will break. And now, if we remember from last lesson, 0.02 equals 2%. So let x be the random variable that assigns to each outcome the profit for the company. A negative value is a loss. The distribution of x is given by the following table. So this tells us that 0.02 of the time they will lose $519. So that's what this means right here. And so basically we have to find the probability that they gain $51, and that would be 1 minus 0.02, right? Because they have to add up to 1, and this gives us 0.98. So this is the probability that x equals 51. So now we want to find the expected value of the profit for the company. So to do this, right, from our definition earlier, we would take the outcome, the first outcome, 51, times the probability of it happening, which would be 0.98, plus the next outcome, negative 519, multiplied by the probability of it happening, which would be 0.02. And now the expected value there is, let me see, is 39.6. Expected value is very easy, and this is also the mean, remember, so the same thing. Okay, for the next one, the distribution of a discrete random variable x is given by the table below. And now, again, this is another probability mass function because it has the outcomes here and then the probability of each outcome happening. So now we have to calculate the standard deviation of x, and we need to round our answer to three digits after the decimal point. So in order to do this, the first thing we need to find is the expected value of x. So let's do that. So that would be negative 24 times 0.4 plus 4 times 0.2 plus 24 times 0.4, and this is going to come out to 0.8. And now once we have this, we need to find our variance, right? Because in order to find our standard deviation, which is the ultimate result of the problem, we first have to find our variance, and then we will take the square root of the variance to find the standard deviation. So our variance here, if you remember our formula earlier, it is the first observation, so this is negative 24, so our first outcome, and then we would subtract the expected value, so 0.8 there, squared times the probability, plus the second outcome, 4 minus the expected value again, squared times the probability, and then for the last one, it is 24 minus 0.8 squared times 0.4. And our variance there is 463.369. And for the last step, standard deviation of x, all we have to do is take the square root of the variance, and that is equal to 21.526. Not a super long problem, but it can be a little bit challenging to remember the variance formula. And so you remember that you have to square right here once you subtract the mean from the value that you're looking at. Okay, for this last problem, we are told that the General Social Survey asked 827 people how many days they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. The results are in the following table. Complete the table for probabilities, then answer the question. So for this one, it doesn't tell us the probabilities of each of these outcomes happening. It just gives us the frequency of their test. So now we have to take the frequencies divided by the total in order to find our probability of each outcome. So for the first one, we would just take the frequency over the total, and we're going to do this for all of them. So 436 over 827, and then 72 over 827, and then, skipped a little too far ahead there. 263 over 827, 72 over 827, 19 over 827, and 10 over 827. So now I'm going to do these on my calculator, and I will write each of them down for you. 27 divided by 827. So the probability of the first one is 0.0326. And I'm sure that you can see on this one that the probability of 0 and 3, 4, and 5 is going to be a lot less than the probability of 1 or 2 days. As you can see, because the frequencies are a lot less there. So you have a higher probability of getting 1 or 2 days waiting than you do of 0, 3, 4, or 5. So 436 over 827 0.527 for that one. And then we have 0.318 for 2. And then we have 0.087, 0.0230 for 4. And for 5, we have 0.0121. So those are our probabilities there. And now for the next part, we need to find the expected number of days that people would wait to seek medical treatment to 3 decimal places. So for this one, what we would do is we would multiply the number of days, right? So we would do 0. So we would do this. We would do 0 times the probability of it happening. And then we would do 1 times the probability of it happening. And then 2 times this one. And then we would do that for all of them, right? And so I already have the answer down here. This is going to end up being This is going to end up being 1.576 days. And right, that makes sense with what I was saying earlier, is that the frequency of 1 and 2 are a lot higher than the others. So it makes sense that this expected value is going to be somewhere in between 1 and 2. So for this last part of this question, this is sort of a concept. And it says, find the probability of the expected number of days that people would wait to seek medical treatment. And so the probability of our expected value, which is 1.576, is actually going to be 0 here. And so if you look on this chart, there's no outcome that says somebody waited 1.576 days. That's just what we found as the expected value. That doesn't mean that that's a value that's actually possible to get. That just means if you average all of them together, that's what you're going to get. So here, usually in a discrete distribution, the probability of the expected value is 0, just like in this problem, because it doesn't occur in the outcomes. And that's basically all I have for you in this one. Thank you for watching, and I hope to see you in the next one.